What if we told you that you temporarily live in a completely different universe than your neighbor? You might think we're crazy, but there is evidence to prove just that. Within our universe, countless variations could exist, starting right outside your front door or after your next thought. Stay tuned, because we're about to show you the scientific evidence for the existence of parallel dimensions in the multiverse. Can't we see the obvious? Many thousands of years ago, people thought the Earth was a disk and the sun and moon were points of light moving across the arc of the sky. Later, they found out that we live on a sphere and the light spots are spheres as well. Then we learned about stars, galaxies, and the vast expansion of the universe. Each time, people had to change their previously limited worldview and face new facts. Just as long, people thought the sun was absolute and would last forever. But today, we know that stars form and pass away, galaxies collide and merge, and now we must face the fact that our universe is very likely only one of many. Although we did not explicitly know of the existence of other dimensions and worlds, there is evidence of their existence all over the world and in all ages of mankind. It sounds far-fetched for rationalists when people argue at the present time with the knowledge of ancient people, or refer to the existence of natural beings like fairies and elves, or even archaeological findings that cannot be explained. Traditional natural scientists further claim that ideas of the multidimensionality of our world are nonsense or simply imaginary thinking. But if we today survey the current knowledge of many disciplines of natural science with an open mind, we must acknowledge that indications of the existence of parallel worlds, other dimensions, and the multiverse are becoming drastically denser. The reason for this are specifically the findings of quantum physics. This discipline of the smallest building blocks of the universe found out that matter splits above a certain threshold into an elusive and above all predictable substance. Quanta, which are elementary building blocks of this world, take on a wave form instead of a particle form above a certain threshold. At first, this sounds even exciting to non-scientists, but physicists know that this means that everything that was previously certain, solid, and definable blurs into a potential, and this undefined potential has even more interesting properties. In fact, scientists can no longer even determine the whereabouts of these waves. It's impossible to determine whether these waves are still in our space, whether the space dissolves at this threshold, or whether the particle waves can form several realities at the same time. The many worlds theory. The idea of parallel universes dates back to 1954 when Hugh Everett III, a student at Princeton University, developed the notion that parallel universes exist that resemble and are connected to our universe. These parallel universes branch off from our universe branches off from others, and among the universes, there can be numerous connections. If your neighbor turns his back on you in the morning after greeting you kindly, and having clearly materialized in your universe, he could be temporarily living in a completely different universe through invisible thresholds. This daring theory has many fascinating but also quite practical dimensions. In parallel universes, for example, world wars could have had different outcomes. If we take this theory seriously, it's also conceivable that species like dinosaurs still live in parallel universes. Due to the temporary overlapping of worlds and dimensions, there are occasional sightings of dinosaurs or strange creatures, such as Bigfoot. Archaeologists have found pottery showing humans with dinosaurs. In addition, objects occasionally turn up in very old rocks that were actually made in modern times. The possibility that the pyramids in Egypt were built tens of thousands or even hundreds of thousands of years ago in our era by a species that used them as power plants or interstellar communication towers could also be explained in this way. Theoretically, it would even be possible for two nearly identical variants of our Earth to occasionally merge, just as galaxies collide and merge into one entity. String theory and the many worlds theory. Many people initially doubted Everett's idea. Reality seemed too crazy, too absurd, and difficult for the human mind to grasp. But further scientific findings came to speak for these worlds. Quantum physics investigates our known world on a subatomic and thus the smallest level. Physicist Werner Heisenberg came up with the idea that we influence the behavior of quantum matter simply by observing it. Another physicist who could confirm this was Niels Bohr. Since then, science has had to acknowledge that quantum particles theoretically exist in all possible states simultaneously, and that our observation influences their behavior, forging them to choose a state at a given moment. What we experience in reality is thus dependent on our attitude, thoughts, and consciousness. Quantum physics shows us through numerous experiments that every decision and every step in this world can lead us to other realities without us noticing it in our everyday lives. Everett's approaches have long been questioned because they are incompatible with basic physical understandings of time. However, we must admit that time is still an elusive as well as describable dimension in physics. On a quantum level, time as well as space lose their meaning and can lead to infinite times and spaces. Up until now, physics has been challenged with uniting the knowledge of quantum mechanics in the microcosm with the macrocosm of the big phenomena. String theory can fill the gap between the two disciplines and thus describe our world as a whole. In string theory, it is assumed that the basic building blocks of matter are not point particles, but tiny vibrating filaments or strings. These strings exist in more than the familiar 3 dimensions of space and 1 dimension of time. If this were true, our world would be composed of at least 10 spatial dimensions. But what about the Big Bang? Everett's many worlds theory states that every time a decision is made or a measurement takes place, the universe splits into different branches. Each branch represents a possible outcome or reality. This means that there are infinitely many parallel universes in which every possible combination of events and decisions takes place. The fact that we could trace the universe back to the beginning, or at least we thought we could, long argued against this. Scientists stumbled upon evidence of a starting point, the Big Bang, by observing the inflation of the universe. Measurements of the cosmic background radiation revealed that the cosmos was a hot and dense soup shortly after its beginning. Before the actual bang, probably existed a quantum fluctuation, which can be described scientifically only to a limited extent. A sure beginning point speaks at first against the theories of the many worlds within a universe. Now, however, there was little real evidence for the Big Bang except for some model calculations. Researchers hoped for this from the new James Webb Space Telescope, but they were disappointed. Instead of providing evidence for the Big Bang theory, James Webb found galaxies that existed at a time when they should not have at all. Since then, it's clear that something cannot be right with the assumption of the Big Bang as the beginning of our cosmos. On the other hand, proponents of string theory and the multiverse theory found evidence for the existence of further space dimensions in the inflation of the universe. Some of these dimensions might exist purely computationally rolled up within ours. These dimensions are so tiny that we cannot perceive them directly. You can imagine a thin tube consisting of only one line. Upon closer inspection, we see that the line is actually not straight, but has curved into an additional tiny dimension. Although the curled-up dimensions are small and hidden, other worlds may be hidden within them. The way the strings oscillate and propagate in the coiled dimensions is even supposedly recognizable from certain properties of observable matter in our universe. Nevertheless, the theories have not yet been proven. Some researchers even found indications in the Big Bang calculations that not only one, but 3 or possibly even infinitely many universes were formed at the starting point. Some of these models foresee that the other worlds are extremely different from ours. If they are tiny, or within them completely different physical regularities apply, we could never travel to them and presumably also not describe them. Other theories envisage that we are connected to and even live in a multitude of other dimensions. In the multiverse, all these possibilities exist together. There are worlds which are similar to ours, in innumerable variants as well as universes which are completely different. A dimension inside our Earth? In Antarctica, scientists measured neutrino particle streams from space. NASA's ANITA Antarctic Impulsive Transient Antenna used a giant balloon to measure neutrino swarms from space high in the cold, dry air of Antarctica. Suddenly, the antennas registered a stream of low-energy particles, or neutrinos, coming directly from the center of the Earth. Neutrinos can only penetrate thin forms of matter, never the entire globe. This means that high-energy particles can actually only be detected when they hit the Earth from space. The measurement suggested the existence of a parallel universe whose intersection is somewhere inside the Earth. The particle stream even allowed conclusions to be drawn that the tau neutrinos had traveled backward in time. In the universe of the origin of particles, time goes therefore backwards, or the time axis of this cosmos is mirrored against ours. Black holes, white holes. Researchers often stick with model calculations or simulations in order to elicit the universe its secrets due to the lack of direct observation possibilities. For example, Albert Einstein mathematically predicted the existence of black holes long before the first real black hole was discovered. Then, just as hypothetically, researchers concluded that black giants in other dimensions or universes might have counterparts in the shape of white holes. Model calculations reveal that white holes repel matter and light, while black holes trap matter and light. White holes hypothetically appear where ideas of time reversal in other dimensions are invoked to explain previously unexplainable phenomena in our cosmos. Our universe has truly an interesting characteristic which can be seen as a further hint for multidimensionality. Wherever an explanation appears, many new questions and variants of the cosmos arise. According to quantum physics, different expectations lead to different results and worldviews. According to quantum mechanics, a physicist can turn at one point and prove these theses in his reality by real observations. He's then rewarded with the Nobel Prize and has a stellar career. In another universe, however, the proof remains missing, or other scientists are right and clear the Nobel Prize for themselves. Do you think this evidence is meaningful? And can you imagine that we can consciously control reality to our own advantage?